This video is going to talk a little bit about multivalent elements or metals. And so what that means is multi means more than one. So these metals have more than one charge. So these are transition metals mostly. So let's go ahead and look at this. A metal that has more than one possibility for its positive charge. And again, those are basically your transition metals, and then a couple more that I'll talk about. So these compounds are going to have one of those multivalent metals in it. And then typically we're going to name that just like we always do. Name of the element. Then it's going to have an anion in it of some sort. So this can now be your nonmetal, or it can be with an IDE ending, or it can be your polyatomic ion. And then that is going to be your negative charge. Okay, so either a polyatomic ion or your nonmetal. Your total negative charge has to equal your total positive charge when we're putting these together. And so let's go ahead and highlight that total negative charge has to be equal to your total positive charge. So all compounds have to end up being neutral with their charges. So first thing you'll do is determine your charge on your metal, and then you will write your Roman numeral to indicate which charge that metal has. So these are a little bit trickier because we've got a couple extra steps. These will all include that Roman numeral, and so we have to know the charge on the metal to be able to write that Roman numeral. So we'll go through a couple examples here. Some of the common ions that we're going to see, these are going to be our negative ones. Okay, so we'll see these attached to our metals. So here's our first example. Copper can have more than one charge. So what we do is we look at our nonmetal here, and we know that chlorine is in group 17. So it's going to have a -1 charge because it's got 7 valence electrons. It wants to gain one more for that full shell, so we know it's going to be -1. So since there's one atom of copper here and there's one atom of chlorine, and we know that because there's no subscripts down here, that means that we would have a copper, and it's going to have a +1 charge because these two added together have to be equal to 0 so that we have a neutral compound. So this shows you going through those steps. Okay. Cation is copper, anion is chloride ending in the IDE, and then our next step is to add in our charge, which we just figured out is a +1 charge. So our Roman numeral that we write into the center here is going to be a 1. So we would name this copper 1 chloride. So a couple extra steps there. Now let's look at this one. Here you can see that we've got 3 of this polyatomic ion and we've got 2 of this. So let's walk through these steps kind of slow here. We know that this is iron again. We look up our polyatomic ion, and that's carbonate. So that's how we're going to start our name. Now we have to figure out our charge so we know what goes in here. So iron is one of those multivalent ones that is not it is a transition metal. Excuse me, I was going to say it's not, but it is. Okay, so we look at this. Carbonate has a charge of -2, and there's 3 of these. Okay, so when you see a polyatomic ion in parentheses with a number outside of it, that's how many we have. So it would be just like writing -2, -2, and -2 3 times, or a total of -6, however you want to think of it. Okay, so this part of the atom has a -6 charge. So that means that the metal part has to have a total charge of +6. There's 2 of those. So we know to get a +6 charge when there's 2, each atom has to have a +3 charge. So +3 and +3 is going to give us that +6 charge we need because we need a total 0 charge. Now this can be confusing, I understand that. So what that tells us is -2, -2, -2 gives us -6 charge because there's 3 of this one. We know there's 2 of this one. We have to have the +6 because these have to be equal to 0. Or you could think of it as -2, -2, -2 has to be equal to +3, +3, which has to be equal to 0. Okay, so we know each one of these irons has a 3 charge, so that's where the Roman numeral 3 comes from. So you can see that these are a little more difficult. So go ahead and pause, go through these and see how you do figuring out the charge, and then we'll go through those together. So go ahead and pause it. Okay, so now looking at this, we know that chlorine has a -1 charge, but there's 2 of those. So we know our total charge is going to be -2 here. So we know our metal charge has to be +2 because there's only 1. So +2 minus 2 is equal to 0. So this would be lead 2 chloride. Here we know chlorine is -1, but there's 4 this time. So our total negative charge is -4. So since there's only 1 lead, we know this charge has to be +4. So it would be lead 4 chloride. Here oxygen is -2. There's only 1 oxygen. There's only 1 manganese. So we know manganese would be +2 because +2 minus 2 is equal to 0. So that's manganese 2 oxide. And then this one's a little trickier. There's 3 oxygens. We know each oxygen has a -2. So we can write it 2 different ways. -2 times 3 would give us a total charge of -6. Or if in your mind it's easier to write 3 -2s, write 3 -2s because we've got 3 oxygens, each with a -2 charge. Now we know we've got 2 manganese, and we know that our positive charge has to be +6 because +6 minus 6 is going to have to be equal to 0. So if we look here, if we have a +6 charge and there's 2 of them, we have to divide this by 2, so we know that each of these manganese is going to have a charge of +3, so it'll be manganese 3 oxide. So here are the answers that you should have had. Okay, so again, these are a little trickier because you have to be able to figure out your charges. Now, covalent compounds are much, much simpler. Okay, much, much simpler. And again, we have binary, so that means we're going to have 2. Since it is covalent, though, we know that these have to be 2 nonmetals. Okay. So here we're going to have 2 nonmetals that are added together. So again, one more time, 2 elements because it's binary. They're both nonmetals because it's covalent. And these are very simple to write their names. You write the name of the first element using a prefix, and I'll show you the prefixes in just a second. The only one you don't use on the first element is 1. If you only have 1 of the first element, you do not write anything. You just write the name of the element. The name of the second element then, still going to end in IDE, and you are going to use your prefix with all of these. Okay, so we'll go through the prefixes and I'll show you how to do this. Here are the prefixes. You just have to memorize these. Most of these you know from math with all your different shapes. Mono is 1, di is 2, tri is 3, like a triangle. Tetra is 4, like Tetris. Tetris, each particle in Tetris has 4 parts to it. Penta, pentagon, 5 sides. Hexa, hexagon has 6 sides, etc. So you just need to make sure you know those. So let's go through an example here. This one has 2, so we would write the prefix di. And then we would write the name of the element. So it would be diphosphorus. And then we would write our prefix here is pentaoxide. So diphosphorus pentoxide. Next example. Silicon, here's one where we just have 1. So we would just write down silicon. We have 2 oxygens, so we would write dioxide. Now what you guys have to remember here is these are both nonmetals. That is the only reason that we're using prefixes. If one was a metal, we cannot name them this way. Okay, so again, your example here. So again, if you look at these, a nonmetal and a nonmetal, a nonmetal and a nonmetal, a nonmetal and a nonmetal. So you have to identify that before you can name your compounds. If they're nonmetals, you use these prefixes. If there has a metal at the beginning, you cannot use prefixes. So you have to make sure you identify that. So pause and name these quick, and then look up your answers. So here, carbon dioxide, I'm sure you guys all knew that one. Here there's a 2, so dinitrogen. 4 here, so tetroxide. Here there's a 4, so tetraphosphorus. 10 here is decoxide. Here, carbon, and there's only 1, so we have to use that mono, so monoxide. So here's a quick little chart just kind of summarizing things up. If we start with a metal or ammonia, it's binary, ionic, we're going to have 2 capital letters. If it's polyatomic, we're going to have more than 2 elements. And if it does not contain a metal, then we know it's going to be covalent. So here's some practice of everything together. So go ahead and pause, write out your answers, remembering the first thing you have to identify is this a metal or if this is a nonmetal. If it's metal, you do not use prefixes. Excuse me. So here are your answers. Sodium oxide, you have to end with that IDE. Here, this is a polyatomic ion, so you should have looked that up, and that's phosphate. Here we have a multivalent, so we had to figure out our charge. Our charge on hydroxide is -1, and there's 2 of those, so that would give us a total -2 charge. So copper has to have a total +2 charge, so that's where this Roman numeral came from. We've got ammonium sulfide here, so a polyatomic ion, NH4, wrote the name, and then we end in IDE. And here again, we just write the name of the metal, the name of the nonmetal with an IDE ending. So that was a little bit of practice kind of putting those all together. And we'll go ahead and pause there